Hi everyone, welcome back. And we just started with signal transduction, and I've already mentioned the few reasons why cell signaling is important, because cell needs to be able to communicate with each other. They have to signal each other of any damage that might have had happened inside the cell. So you could have DNA damage, for instance. You can have intracellular changes. You have to make sure your nutrient levels are okay, so when your body needs to make energy or ATP, then you have all those nutrients that you need. So basically cells need to communicate with each other for all these different sorts of things. Then there is this idea of cells being able to talk to each other for the reasons that I just mentioned. And because cells are able to communicate with each other, they are then able to work together and produce efficient results. um, and I think I briefly pointed this in my last video, was that it is also involved in the regulation of cell growth and division. And because it is involved in those two things, those are very, very important to study cancerous cells, to study tumor cells. So that's why it's really, really, really important. Now, these are the general principles of signal transduction. So how this works is you have a signal, and this signal is usually outside of the cell. Okay, so let me try and draw this. Okay, so you have your cell, and this cell needs to communicate something to this cell, and this is a very simplified version. It usually is thousands and thousands of cells, but just to give you guys an idea, just to explain this concept. So you have a cell that needs to give a signal to this cell here. It will produce a primary messenger. Okay, this will produce a primary messenger, and this primary messenger will basically contain the signal. And this primary messenger is like is a signal for the other cell. So when this other cell receives it at this, now this other cell is it's not just going to accept this primary messenger and take it in. No, it's not going to happen that way. What this primary messenger will do, it will first go to the cell surface receptor. So there'll be receptors for it. Okay, so all cell membranes have receptors on them, so it will find the right receptor, and then the binding of the primary messenger to the receptor will lead to changes inside the second cell that needs to react, and will go about doing whatever it needs to. So you have your signal, then the signal needs to be received. So the signal is outside the cell, the reception is on the cell surface receptor. Okay, then there is the transduction. Transduction basically means, what do we do? What do we do with the signal? Yes, we've received it, we understand it. Now what do we do, right? So whatever that signal is telling you, you're supposed to do that. So that's where the amplification part comes in, and that's where, oh, I have written it out already. That's where the secondary messenger comes in, and we will talk about that shortly in detail. And after the transduction, you basically have response, and this response is inside the cell. Okay, so you go from outside of the cell to the inside of the cell. So this is how it works in a forward direction. Now you cannot have a signal going on all the time. It's just like a switch light. You cannot have a light on all the time. You need to turn it off when you leave the room, or at night time, or when you're sleeping or something, right? So there is that process of being able to stop the signal. So either, and this could work in different ways. The stopping of signal could happen in different forms, in different ways. So you could go from this step to here, it can stop it here. You can go from here to reception, you can stop it here, or you can directly go back to the signal. So these are referred to as the feedback. Come on, work. There we go. Not really. Okay. Feedback. Okay, something's gone wrong. I'll just continue with this in the next video.